Next, let us look at stationary points. Usually, there are three types of stationary points. We have, number one, stationary points known as a maximum point, which normally takes the nature illustrated. So curves that curve upwards. This is called a maximum. The point of turning in this case is called a maximum point. Next, we have minimum points. So that is a minimum stationary point. And then next is what we call points of inflection. So points of inflection can take two forms. We have that as a point of inflection, or so both. It can take the first nature or the second nature. We will look at the difference between the two when we will be looking into details the nature of points of inflection. Let us consider the curve y is equal to x squared minus 2x plus 3. So for this curve, the gradient function dy dx is equal to 2x minus 2. At turning point, dy over dx is 0. So that means that our value 2x minus 2 is equal to 0. And therefore, x is equal to 1 at the turning point. So we can get the equation of the turning point. The value of y at the turning point We can get the nature of the turning point by considering a value to the left of x minus 1 and a value to the right of x. So we'll have a table. So we have the x value So we have x value at x is equal to 1, the y over the x is 0. Take a value to the left of x is equal to 1 at x is equal to 2, the y dx will be 4, will be positive 2, and at x is equal to 0, the y dx will be equal to negative 2. So the sign of gradients in this particular case is negative 0 positive. So negative gradients lines usually flow from left to right. Zero gradients is a turning point, and positive gradients flows from right to left, and therefore this type of turning point is a minimum. So this gives us a minimum turning point. Let us consider another case. Consider the curve y is equal to negative x squared minus 2x plus 3. So in this case, the gradient function dy over dx is equal to negative 2x minus 2. At turning point, dy over dx is equal to 0. So that means negative 2x minus 2 is equal to 0. X will be negative 1 at the turning point. We do the same as we have done in the first case so that we see the nature of the turning points. So we will need to see how the graph would be to the right and to the left of the turning point. So we have the x value, we have dy over dx, and then we have the sign of gradient. At x is equal to negative 1, dy dx is 0. So the sign there, this is 0. To the left of the turning point, take negative 2. When x is negative 2, dy dx is positive 2. So the sign of the gradient is positive. To the right of negative 1, take the point 0. Dy dx is negative 2, and therefore the sign of the gradient is negative. The nature of the turning point would be positive, zero, negative. And this gives us a maximum. This is a maximum point. Given y is equal to 1 plus 4x cubed minus x raised to power 4. Dy over dx is equal to 12x squared minus 4x cubed. At turning point, dy dx is equal to 0. And this is equal to 12x squared minus 4x cubed for the given curve. We'll have 4x squared into 3 minus x is equal to 0. So from here, x is equal to 0 or x is equal to 3. So the turning points for this curve will be at points x is equal to 0 and point x is equal to 3. We want to test the nature of this turning point. At x is equal to 0, we take a point 1 to the left, x is equal to 0, which is -1, and 1 to the right of x is equal to 0, which is +1. Substituting into the gradient function, we'll have 12 into -1 squared minus 4 into x -1 cubed. So that gives us 12 plus 4, which is equal to +16. So the nature of our turning points will take the pattern +0, 0, and this is a point of inflection. So in summary, for various types of stationary points, the gradients at stationary point will be 0. For a maximum, gradient to the left is positive, while gradient to the right of the turning point is negative. For a minimum, the gradient is negative to the left of the turning point and positive to the right of the turning point. For points of inflection, we can have negative, 0, negative, or positive, 0, positive.